right. So in this lesson, we're going to look at Newton's laws and kind of how this gentleman here on the left, Sir Isaac Newton, developed a set of rules which really changed what physics looked like in the 1600s. So Isaac Newton is a mathematician and a scientist in the late 1600s. He's generally viewed as the father of at least modern classical physics and derivative calculus. In our previous unit, we talked about graphs of motion, looking at how those different graphs of motion relate to one another. That's derivative calculus. That would be Sir Isaac Newton that kind of came up with a lot of those ideas and a lot of those connections. Some other kind of cool things about Sir Isaac Newton, in his spare time outside of the scientific realm and outside of developing calculus, he was a knight. He was also in charge of the Royal Mint for about 27 years. What the Royal Mint did in England is make and produce money. A lot of the techniques he started to develop, or a lot of techniques still used by modern governments to prevent counterfeiting, were developed by Isaac Newton and his contemporaries in the Royal Mint during this time period. Some other things that are kind of cool about Isaac Newton: he was generally viewed as kind of a loner. He did not like to associate with people, did not like to socialize. He was for a while the president of a society called the Royal Society, which was a group of scientists and philosophers who got together and discussed the most important scientific and philosophical problems of the day. You can kind of imagine this group of, well, very smart intellectual men. There are no women that are part of the Royal Society, that get together and discuss what are the big issues in today's world. The other weird thing about Isaac Newton, his father died when he was very young. His mother remarried. His mother moved to a big estate when she remarried. If he had followed what his mother wished him to do instead of going to school and then to college, he would have become a farmer. He did very well in school. He got accepted to a very good college, and his mother wanted him to come back home and tend the farm, and he basically said, "No, this is the opportunity of a lifetime for me. I have to go to college." And, well, our world is better because he decided to go to college and not follow his mom's advice and become a farmer. So there are three laws that we generally refer to as Newton's laws when we talk about physics. The first law is what I generally call the law of inertia. It says an object will stay in a constant state of motion unless acted on by a net external force. What that means excuse me, is that the velocity of an object will stay the same unless it's acted on by a net force outside of that object. When we talk about net external force, that suggests that there could be external forces acting on an object, and as long as they cancel out, we could still have a constant state of motion. A net external force would mean that those forces don't cancel out. The second law is very similar to the first. The second law says what happens if there is a net external force acting on the object, and the object will experience acceleration. Its state of motion will change. Now, there are a couple different ways an object can accelerate. It can speed up and slow down, but it could also change directions. Remember that acceleration is a vector. It includes both a magnitude and a direction component to it. And the third law is, in some ways, one of the more important and useful laws, but is also in some ways one of the most misunderstood of Newton's three laws. Generally, the third law is what's called the action-reaction law. The way it's normally stated is for every action there's an equal and opposite reaction. I don't like that statement because it suggests the reaction happens after the action. In reality, those two things are happening at the same time. I write it this way: if object 1 applies a force to object 2 applies a force on object 1 that is equal in magnitude and opposite in direction. So if you're putting a force on one object, that object is putting a force of the same magnitude and opposite direction on you. So if we kind of go through, so that's kind of a quick overview of Newton's three laws. What we'll start to do is start to look at each of these laws in a little bit more detail in the next set of lessons as we start to describe some of these. We'll do a set of lessons primarily on the first law, a set of lessons primarily on the second law, and we'll interweave the third law throughout that because it does show up in lots of different places.